Alright, so this is probably not the best way to do this. The best way to do this is probably use de Moivre's theorem, which is z equals r parentheses, what is it, cosine theta plus I sine theta. And I'm missing something here. I think it's r to the n. I believe that's right. Yeah, that's not right. So let me refresh that. It's z to the n equals r to the n, parentheses, cosine n theta plus I sines of n theta. There we go. That's de Moivre's theorem. So we let z be the 5 plus 12i. We're talking about the fourth root here. So n is 1/4. Now we're still going to have to find the angle. And this is not a pretty problem. I mean, it's still going to be a calculator problem. Plain and simple. There's nothing I can do about it. But I bet we can get close. Anyway, since we're using technology anyways, we'll just see what she looks like. Anyways, I got to have an angle, right? Now, we've already done this one before. We found the angle to be 1.176 radians, and we found the radius to be 13. So 1.176. Yeah. And we're just going to plug some crap in. So z to the 1/4 is going to be 13 to the 1/4. And we have the cosine of 1/4 of that thing. And this is how things would be presented to you on your challenge exam. They'd say, which of the following represents this thing in a plus bi form? It's more or less there. And then we have I sines of 1/4 of 1.176. This would be a lot cooler if they were pretty things, but they're not. So let's just check for numerical equivalency here, and that's as far as I really want to take that thing. Very silly of the author of the textbook to use an example that has such horrible numbers, but I didn't write the textbook, so who knows about that. Now I have some rounding on my angle, so I'm probably not going to be as 100% accurate as just pushing buttons in a calculator, even though I am still pushing buttons in a calculator. Data type. What's my data type? Close, close. Is it right here? I bet it just can't do it. No, it did it. Alright, so there's what we have. Now the original thing was 5 plus 12i. It seems really silly to do a lot of this stuff anymore. I mean, we have technology. No, we're off a little bit somewhere. It's probably because of the rounding of that angle. I don't know. I don't know. Anyways, that's de Moivre's theorem. Now here's the most important stuff, is just the basic vectors. Given the vectors shown, sketch 3u minus 4b. So I'm going to write out these things in component form. I talk about vector u. Its component form is 1, 1. Runs 1, rises 1. I talk about vector v. Her component form is fall back 1, rise 2. Alright, back 1, rise 2. That's her component form. So when you do 3u minus 4b, 3 of vector u would obviously be 3, 3. And then 4v, if we multiply by 4, is negative 4, 8. So what we're doing here is we're doing 3, 3 minus negative 4, 8. And we're just going to focus on like terms, all right? 3 minus a negative 4 is going to be 7. 3 minus 8 is going to be negative 5. So I need a vector that goes right 7 and then down 5. Right 7, 3, 6, 7, down 5. And that is this new vector, we'll just call it z, which is 3 u's minus 4 v's. And I guess I need to stop here in a second. Yeah, I'll try and finish the rest of this up during my planning period today. If not, I don't know. Y'all shouldn't have skipped on me, bro.